I hope you remember what is an even function. When you are given one function f of x, how can you recognize whether it is an even function or an odd function? It may not be anything, of course.
F of x equal to f of minus x.
Yes.
F of x equal to f of a minus
Right.
f of.
Correct. So when for the given function f of x, if you replace x by minus x, if you get this f of minus x as again plus f of x, then we say the given function is an even function. Geometrically, what happens, you see, when it is an even function, geometrically, it will be symmetric about what you call this y-axis. It will be something like this, right? The function will be, graph of the function will be symmetric about what you call y-axis when it is even. Similarly, if you recall, when you can call a function as an odd function, as somebody said now, when f of minus x is equals to minus f of x, then we say the function is an odd function. And geometrically, you see what happens when you draw the graph of an odd function, it will be always symmetric about what you call the origin, right? It will be symmetric about what you call the origin, right? So it will be symmetric about origin like this. Now, mathematically, we know about what you call even and odd functions. Then see, recall, for example, there are a few other mathematical things which you need to recall now. Perhaps you remember in integration, let us say you are given one function f of x. It is defined in the interval minus pi to pi, right? Some other numbers also, in general, minus a to a, that is also fine. For example, you are integrating this function between these values, wherever it is defined. By chance, if this f of x is an odd function, right? You are given this function, which is defined in the interval minus pi to pi, and I'm just considering this is an odd function. Then can you recall what may be the integral value? This is an odd function now, right? Understand it this way. This integral value is 0 when the function f of x is odd, right? What happens, you see here, when you evaluate the integral, I hope you remember, while evaluating the definite integrals, those definite integrals give us area under the curve, isn't it? So let us say if this is the function what you are given, it is an odd function, and you are integrating this function between minus pi and plus pi, right? You are just evaluating between these values. So whatever the area you get between, because it is symmetric, symmetric about origin. So whatever the area you get between minus pi and 0, the same area you will get between even 0 and pi also, right? When you speak in terms of area, we only consider the absolute values, right? We simply ignore the sign. But but mathematically, when you evaluate only the integrals, since this area is below the x-axis, we'll get this value as negative. And the value, since this area from 0 to pi, since the area from 0 to pi is above the x-axis, we'll get this integral value as positive. But numerically both are same, but one is negative and the other one is positive. That's how when you add these two, we'll get the integral value as 0. But when it is area, we take absolute values and we add them, right? So when you evaluate an odd function, when you integrate an odd function between these kind of values, it may not be only minus pi to pi. It may be from minus a to a, minus anything, right? Minus of that to positive of that. When you evaluate integration of odd function between those values, definitely the integral value is 0. You need to remember this, right? When the function is defined in this kind of interval, not in a general way. When the function is defined in the interval minus pi to pi, and if you are integrating that odd function, right? If you take f of x as an odd function, then the integral value is 0. That's one idea. In a similar way, let us say you are given one even function, right? You are given an even function, and also it is also defined in the interval minus pi to pi. Maybe minus a to a in general, anything is okay. Then can you expect what may be the value of this integral?
2 into integral 0 to p f of x dx.
Yes. So this can be written as 2 times integration from 0 to pi fx dx. That's how it is, because when it is even function, it is symmetric about y-axis. So whatever the area you get from minus pi to 0, you will get the same area from 0 to pi. So that instead of calculating from minus pi to pi, you can only evaluate this first right half, 0 to pi, and you can just multiply it by 2 to get the total integral value, or of course total area, right? If it is in terms of area, we take absolute values, otherwise we take what you call the regular value. So when this function is an even function, we can write integration from minus pi to pi f of x dx as 2 times 0 to pi f of x dx. Now keep these things in mind, and now let us rewrite what you call these Fourier coefficients. Now let us say you are given one function f of x, which is defined in the interval minus pi to pi. Okay. If that is the case, how can we write the Fourier series? It is the regular way, a naught by 2 plus a n cos n x plus b n sin n x. And what are the Fourier coefficients here? A naught can be written as normally 1 by pi into integration from minus pi to pi fx dx. This is a regular formula what we use. And then similarly, a n can be calculated with this idea, 1 by pi into minus pi to pi fx into cos n x dx. Right? Then bn is 1 by pi into minus pi to pi fx into sin n x dx. So these are the regular formulae we use to calculate the Fourier coefficients. Now let us take them in a special case. Let us say the function what you have considered is even. Right? Understand? You are now given an even function which is defined in the interval minus pi to pi. Right? You are given an even function which is defined in the interval minus pi to pi. Then can somebody expect what may be a naught?
2 by pi integral 0 to p
Yeah.
f of x dx.
Exactly. So this is an even function. So we can rewrite this integral as from 2 times 0 to pi. So it becomes, as he said, 2 by pi integration from 0 to pi fx dx. Fine. Then anything about an? See, the function f of x is an even function, and as we know already, cos function is also even, right? When you multiply two even functions, the result, the product is also an even function. I hope you remember this idea, plus plus, plus minus. If you just consider plus as even function and minus as odd function, right? When you multiply two positive signs, it is positive. When you multiply a positive and negative sign, it is negative, correct? And even similarly, when you multiply two negative signs also, it is positive. Similarly, when you multiply two even functions, if you take plus as even and minus as odd, so when you multiply two even functions, again it is positive, even. When you multiply an even and an odd function, right, the result is an odd function. And even when you multiply two odd functions, again the product is an even function. So keeping them in mind, an can be written as, since the product, the integrand here is an even function, so we can even write it an as 2 by pi into integration from 0 to pi fx into cos n x. Fine. Can somebody expect what may be bn? You can use this idea. How much? Right. Look at this. The function of x is an even function, and I hope you remember sine is an even, odd function, right? Cosine function, cos is an even function, and sine is an odd function. Sine odd, but function f of x is even. When you multiply these two, one odd and an even function, the product is definitely an odd function. When the integrand is an odd function, the integral value will be simply 0. So when the function is even, and if it is defined in the interval minus pi to pi, then the Fourier series expression of such a function includes only cosine terms. Understand, this can be taken as an object type question, right? The function what you are given is an even function, and even it is defined in the interval minus pi to pi. Then the Fourier series of f of x includes only cosine functions. The coefficients of all sine functions will be zeros. Okay, that's one observation. Then when you take f of x as an odd function, can somebody tell me, can somebody expect what may be a naught?
0.
Right. Since the integrand here is odd function, since f of x is an odd function, the integral value here for a naught is simply 0. Then what about an?
0.
Right. Since see, function f of x is odd, but the cos is even function. When you multiply an odd and an even function, the product is again an odd function. Since the integrand is odd, the integral value is 0. Fine. Then what about bn? Now we are multiplying two odd functions. F of x is odd, even sine is also an odd function. When you multiply two odd functions,
Pi integral.
the product is even function, so that we can write bn as 2 by pi into integration from 0 to pi fx into sin nx. So you can expect, you see, what may be a statement, what may be a conclusion here. When you are given an odd function which is defined in the interval minus pi to pi, its Fourier series includes only sine functions, right? So both a naught and coefficients of cosine functions, everything will be 0. Okay. When the function is odd, which is defined in the interval minus pi to pi, it can be represented as a Fourier series of odd functions only. Understand the statement. When the function is odd and it is defined in the interval minus pi to pi, then Fourier series can be represented again in terms of only odd functions. I mean to say, you are representing them only in terms of sine functions. And as we know, all sine functions are odd. So I'm saying when the function is odd and it is defined in the interval minus pi to pi, then f of x can be represented only in terms of odd functions, sine functions. Okay, so these two important points, keeping them in mind, now you see I'm just concluding all the things together. If so, these things are highly important for us. If f of x is even and is defined in minus pi comma pi, then the Fourier series of f of x is, as we discussed till now, when it is an even function, it includes only cosine functions, right? Therefore, it can be written as f of x is equals to a naught by 2 plus summation an cos nx. For sure, we know bn is 0. That's why I'm not writing that. And here, a naught is equals to, as we discussed already, 2 by pi into integration from 0 to pi fx dx. Right? And an is equals to 2 by pi into integration from 0 to pi fx into cos nx. Fine. Similarly, when the function f of x is an odd function, and as usually if it is defined in the interval minus pi to pi, then the Fourier series of f of x, as we discussed, when the function is odd, then it includes only sine terms. So we can write f of x is equals to summation bn sin nx. So from here you can understand what is bn, you see, where bn is equals to, it is 2 by pi into integration from 0 to pi, what you call f of x into sin nx dx. So using these ideas, see, when you are given a question, nothing will be mentioned in the question. When the given function is defined in the interval minus pi to pi, that should be your first observation. When it is defined in the interval minus pi to pi, then observe whether it is even or odd. In case if it is either even or odd, accordingly we can use either of these two. We have an advantage when they are even, when the function is either even or odd. So we need to just make use of those ideas. So we had seen one problem a few days ago. See, when the function f of x is, this is the function actually what you have considered, and it is defined in the interval minus pi to pi, right? See, there are few functions, certainly, though they are defined in the interval from minus pi to pi, they may not be either even or odd. See, if you look at this function x square plus x, individually, if you take only x square, it is an even function. If you take only x, it is an odd function. But when you add these two, it is neither even nor odd. For such a function, for such functions, we just take the regular formula of calculating Fourier coefficients. When the function exclusively when it is either even or odd, then accordingly we take these formulae, right? That's the story here. Now let me take a question to make use of these things. Let's take this question. Find the Fourier series of f of x is equals to sine x. Let us see what happens. Comma 0, not 0, I'm sorry. Minus pi less than x less than pi. Right, so x takes values between minus pi and pi, and for this interval we need to find out what you call the Fourier series of sine x. Right, first point, the interval is from minus pi to pi, that is clear, and you are given the function as sine x. Can somebody tell me whether sine x is even or odd?
Odd function.
Definitely, right? So I'm just writing that since the given function f of x is equals to sine x is odd. Since it is an odd function, certainly, when it is an odd function, definitely we'll get the series only in sine terms. So we know both a naught and an are equals to 0. Since it is an odd function, we'll have what you call a naught and an as 0. Therefore, the Fourier series, as we written already, I'm just writing it again for convenience. The Fourier series of f of x is f of x is equals to summation bn into sin nx. Okay. Now here, what is bn? Bn is equals to, as we know, it is 2 by pi into integration from 0 to pi. How much it is? F of x into sin nx. So it is equals to 2 by pi times. I'm just substituting, 0 to pi. What is the function f of x? It is sin x. So we have sin x into sin nx dx. Correct? For convenience, if you want, I can also write it like this. You see, 1 by pi into integration from 0 to pi. I'm just multiplying this 2 inside, nothing else. 2 sin x into sin nx. I hope you get some idea now. It is very much similar to 2 sin A sin B. If you can recall some of the trigonometric transformations, you can identify this. When it is 2 sin A sin B, come again. Yes, cos of
A minus B minus cos of A plus B.
Superb. So it is cos of A minus B minus cos of A plus B. Right? We can use this simple trigonometric transformation to rewrite this. Okay. So therefore, we can write Bn is equals to 1 by pi into integration from 0 to pi. You can just compare these two. You see, when you compare them, you can understand A is equivalent to x and B is equivalent to nx. Right? Keeping them in mind, I'm just writing it. You see, it is cos of A minus B. So it is x minus nx minus cos of A plus B means x plus nx dx. So it is equals to 1 by pi into integration from 0 to pi. For convenience, I'm writing this again. Cos of, you can just take x common from them. Right? So when you take x common, you can easily integrate it. It is cos of 1 minus n into x minus cos of, here also if you take x common, we'll get it as 1 plus n into x. Now you can easily integrate these two functions. So it is equals to 1 by pi into, see what happens when you integrate cos. Integration of cos function is, I hope you remember, it is sine of 1 minus n into x divided by 1 minus n. Right? When it is cos nx, integration of cos nx is, as we know, sine nx, and this n, the coefficient of x, whatever you have, that comes in the denominator. Since the coefficient of x is 1 minus n here, 1 minus n, you'll get it in the denominator. Minus, similar way, here also when you integrate this cos function, we'll get it as sine of 1 plus n into x divided by 1 plus n. And the limits are from 0 to pi. Now, look at this function, carefully. After integrating this, we got a 1 minus n in the denominator. When it is 1 minus n in the denominator, what if we take n is equals to 1? Normally, while calculating bn, we must know, n takes values from 1 to infinity. So it must be valid even when n is equals to 1. But here, if you take n is equals to 1, we'll get a 0 in the denominator, right? That's how we'll say this integration is valid only when n is not equals to 1. Right? So this integration is true when n is not equals to 1. When n is 1, no, this is not correct. We cannot take a 0 in the denominator. Correct? So then it is equals to 1 by pi into, now we need to substitute the limits. Look at them carefully. See what interesting thing you are getting here. You see, you have sine of 1 minus n into, when you substitute the upper limit pi, you will get it as sine of 1 minus n into pi. See, when n is an integer, even 1 minus n is also an integer. So we'll get it something like this, some sine of k into pi, if you take k is equal to 1 minus n. Right? For whatever the integer k, sine k pi is 0, right? Yesterday only we discussed this. When you substitute pi there, definitely we'll get it as sine of n pi as 0. Not only here, even this here also. When you take x is equals to pi, both the terms become 0. Not only for the upper limit, even if you take x is equals to 0, right, it becomes simply sine 0. Of course, in both the terms, they become sine zeros. So that we'll simply get, for upper limit and even for lower limit, we'll get everything as a 0. So what you got here? I'm just writing that, you see. Therefore, we got Bn is equals to 0 when n is not equals to 1. But then what happens if n is equals to 1? We need to see that. If you take n is equals to 1, I'm just using again this formula. You see where you are. Here it is. I'm just using this formula by taking n is equals to 1. When n is equals to 1, Bn becomes B1. Right? You're taking n is equal to 1. B1 is equals to 2 by pi integration from 0 to pi. Here you will get sine x into sine x again. You're taking n is equals to 1 dx. Sine x into sine x dx. I'm just continuing this, you see. B1 is equals to, therefore, B1 is equals to, it is 2 by pi into integration from 0 to pi sine square x dx. Right? I hope you remember this trigonometric transformation as well. When it is sine square x, we can write it as 1 minus cos 2x divided by 2. So this is equal to, you can cancel this 2, you see. So then we'll get it as 1 by pi into, now if you integrate this, when you integrate 1, it is x, minus when you integrate cos 2x, it is sine 2x divided by 2. And the limits are from 0 to pi. So it is equals to 1 by pi into, when you substitute the upper limit x is equals to pi, it is first of all pi, minus if you take x is equal to pi here, it becomes a sine 2 pi, sine 2 pi value is again 0. That these two are for upper limit. Then when you take lower limit, if you take x is equals to 0, it is 0. And even when you take x is equal to 0 here in the second term, sine 0 is also 0. So except this, we won't get any other terms. I mean, the remaining all are zeros. So I'm just stopping this here itself. And hence see what happens. We can cancel this pi also, Therefore, we'll get simply B1 is equals to 1. And therefore, you see the interesting thing. The Fourier series of f of x is equals to sine x in the interval minus pi to pi is f of x is equals to b1 into sine x, right? Why only b1 into sine x? Because remaining all are zeros. b2, b3, b4, everything, they're all zeros. We are getting only b1, and that too it is also 1 only. So it is equals to 1 into sine x. What does it mean? Understand? The function what you are given is a trigonometric function. And in fact, you are trying to represent that in terms of trigonometric functions. And more particularly, because it is defined in the interval minus pi to pi, we have tried to represent it only in terms of sine functions. That's how you got sine x is equal to sine x, right? Nothing special in that, right? But see, for the same problem, for the same function sine x, if you try to find out the Fourier series in the other interval, I mean in the interval 0 to 2 pi, you will certainly get some other issues, right? though it is an odd function, if the interval of definition is from 0 to 2 pi, you will get them certainly other values. Okay, so this is how you can find out the Fourier series expansion of either even or odd function. Anyway, we'll continue this.